Welcome to our Earth Science class. This is Earth Science for STEM, Quarter 1, Week 1 of the Module 1, Lesson 2. Our learning competency describe the characteristics of Earth that are necessary to support life and explain that the Earth is consists of 4 subsystems across whose boundaries matter and energy flow. We are going to focus on the 4 subsystems across whose boundaries matter and energy flow. This is Lesson 2. Explain that the Earth consists of 4 subsystems across whose boundaries matter and energy flow. The Earth is a system, but it has parts. These different parts interact and are interrelated to one another. The changes in one part cause changes to the other parts. Their interconnection plays a crucial role in the maintenance of a balanced Earth. At the end of this module, you will be able to explain that the Earth is consist of 4 subsystems across whose boundaries matter and energy flow. Explain what the spheres of the Earth made up of, and explain how the spheres interact with each other. Everything in Earth's system can be placed into one of 4 major subsystems: land, water, living things, or air. These 4 subsystems are called spheres. Specifically, they are the lithosphere, land, hydrosphere, water, biosphere, living things, and atmosphere, air. The 4 Earth subsystems are: first, atmosphere, which makes up all the gases in our planet. The geosphere or lithosphere, which includes all the soil, rocks, and minerals present in the crust to the core of the Earth. Hydrosphere is composed of all the water on Earth in any form: water vapor, liquid water, and ice. Biosphere is comprised of all living things and the areas where they are found. It includes all microbes, plants, and animals. Matter and energy move and cycle between the 4 different subsystems to make life on Earth possible. Here are the 4 subsystems: air, water, land, and life. First, the atmosphere. The word atmosphere comes from the Greek word atmos, which means gas, and sphaira, which means globe or ball. The atmosphere makes up all the gases on Earth. It extends outward about 10,000 kilometers from the surface of the Earth. It is composed of 78.1% nitrogen, 20.9% oxygen, and 0.9% argon, and 350 parts per million carbon dioxide and other compounds. The atmosphere has different layers. Layers of the atmosphere are troposphere, stratosphere, mesosphere, thermosphere, and exosphere. The troposphere extends to about 14.5 kilometers above the Earth's surface. It is the lowest layer where the weather forms. The stratosphere is found 14.5 to 50 kilometers above the Earth's surface. The ozone layer that protects the Earth from the sun's harmful UV radiation is found in this layer. The mesosphere extends from 50 to 85 kilometers above the Earth's surface. It protects the Earth from the impacts of space debris. The thermosphere is found 85 to 600 kilometers above the Earth's surface. It has charged particles that are affected by the Earth's magnetic field. The particles create the auroras or northern and southern lights. And the exosphere is the farthest layer. It extends to about 10,000 kilometers above the surface of the Earth. Here is another example of that. We have the troposphere, the stratosphere, mesosphere, and ionosphere. Next is lithosphere or the geosphere. It's composed of the crust, the outer layer, mantle, and the core. The crust is the outermost layer of the geosphere. It is made mostly of silicate materials. There are 2 different types of crust: the oceanic and continental crusts. The thin oceanic crust that lies beneath the oceanic floors is about 5 to 10 kilometers thick. On the other hand, the thicker continental crust that makes up the continents is about 15 to 70 kilometers thick. The mantle, which lies just below the crust, is made mostly of silicate rocks, rich in magnesium and iron. It is almost 2,900 kilometers thick. It has increasing temperatures at increasing depths. For instance, the layer with the lowest temperature is the one right beneath the crust, and this layer, which is soft enough to flow, causes the plates of the crust to move. On the other hand, the layer with the highest temperature is found in contact with the heat-producing core. The core, which has radius of 3,400 kilometers, is the innermost layer of the Earth. It is made up of iron and nickel. It is the source of internal heat because it contains radioactive materials that release energy as they decay into more stable substances. So this is the lithosphere, the solid part of the Earth. Next is the hydrosphere. Hydro is a Greek word which means water. Hydrosphere is composed of all the water on Earth in any form, like water vapor, liquid water, and ice. It is comprised of 97.5% salt water and 2.5% fresh water. It includes all bodies of water such as oceans, lakes, rivers, and marshes. Clouds and rain are also part of the hydrosphere. The water on Earth is constantly moving. It moves through the oceans in currents. Warm waters in the tropics move toward the poles, while cold water from the polar regions move toward the tropics. Water also flows into streams and rivers and through the rocks underground. It can also move from the Earth's surface to the air by evaporation and then fall back to Earth as precipitation. It even moves into and out of the bodies of organisms. Next is the biosphere. Bio is a Greek word that means life. The biosphere is comprised of all living things. It includes all microbes, plants, and animals. It extends to the upper areas of the atmosphere where insects and birds can be found, and it also reaches the deep parts of the ocean where marine organisms can still survive. We try to look at the picture. Organisms interact with other spheres to survive. Many organisms need oxygen and carbon dioxide from the atmosphere to carry out life processes. Water, which comprises the hydrosphere, is also important to organisms. Finally, the rocks, soil, and minerals constitute the geosphere. Sphere also support life. Okay, this is the biosphere. And now for the application. So we have the four spheres or Earth subsystems. We have hydrosphere, lithosphere, atmosphere, and hydrosphere. Okay, if you're riding a plane when you are riding a plane when you noticed that the pilot seems to go higher than its normal flying zone. You feel that pressure inside your ear starting to increase. Then suddenly you notice that instead of lower temperature can be felt, you feel that you're sweating. One of the passengers asked, "Where are we now?" With the knowledge of the different layers of the atmosphere, how will you explain it to her? Okay, you may write that in your answer sheet or a sheet of paper to be submitted to me. Then for your reflection, after learning from the module, I realized that as a pact to Mother Earth, I promise to. You complete that sentence. Okay, that is for your reflection. Okay, for your enrichment activity, James Lovelock used the Daisy World model to illustrate how the biosphere is capable of regulating its environment. Research and write a 50 to 100 words report with illustrations on the Daisy World model of James Lovelock. Write this in your answer sheet. I will be providing you with the video later on the last part of this video. Okay, this is the Daisy World. Okay, try to look at that. This is the schematic model of the daisy world, whose surface is covered by black and white daisies and empty area. The temperature of daisy world is related on how much energy is received and how much is reflected. The difference is the amount of solar energy absorbed. The amount of energy reflected back to space depends on the planet's albedo, or the fraction of light energy that is reflected. The albedo in turn depends on the coverage of white and black daisies. The heat radiated to space is a function of how much energy is absorbed. This will be followed by a video of the daisy world. Okay, then after that, you're going to answer this assessment part. Okay, you read. You have numbers 1, number 2, number 3, number 4, number 5. Write your answer in your answer sheet, which will be submitted later on. Okay, thank you very much. I'm going to post your video later.
Daisy World is a simple planet. Like the Earth, it orbits a star, which, like our Sun, is getting progressively hotter with age. Unlike Earth, Daisy World has a very simple atmosphere, with no greenhouse gases like carbon dioxide to warm it up. And it only has 2 sets of inhabitants: black daisies and white daisies. The black daisies absorb incoming solar radiation, so they warm up. And as they warm up, they radiate heat, warming up their surrounding area. The white daisies, on the other hand, reflect the sunlight and stay cool. For both colours of daisies, 22.5 Celsius is the optimum temperature for growth. Now let's see what happens throughout the life cycle of Daisy World as things warm up. At first, Daisy World's young sun is cool and the planet is rather cold. And the heat-absorbing black daisies are at an advantage. The black daisies proliferate and slowly spread out from the warmer equatorial regions until they cover most of Daisy World, turning it black. So Daisy World can absorb heat and warm up. As the temperature gets nearer the 22.5 Celsius optimum for all daisies, life gets easier for the white daisies, who then prosper. At first, they grow best at the warm equator. Then they slowly move out, finding a niche alongside the black daisies. But in areas of high solar radiation, the white daisies do best, as they cool their environment. Whereas in areas of low solar radiation, black daisies predominate by warming their environment. In all areas, the numbers of black compared to white daisies depends on the proportion of heating or cooling necessary to maintain the optimum growth temperature. But Daisy World's sun is still getting hotter, and soon the black daisies find it hard to cope, whilst the white ones stay cool. The white flowers soon outnumber the black ones, and Daisy World becomes whiter and whiter. The white planet can reflect the increasing solar radiation and stay cool, but the sun gets hotter still. Eventually, the planet gets too hot, and even the white daisies can't cope. Daisy World dies. 22.5 Celsius is the optimum growth temperature for both black and white daisies. The black daisies work with the sun and warm the planet. We call this positive feedback. White daisies work against the sun and cool the planet. We call this negative feedback. In daisy world, we're concerned with the combined effects of both positive and negative feedback. This graph represents the temperature of daisy world based on changes in solar luminosity alone, without the influence of the daisies. If we now add the daisies, we get this curve, which shows both positive feedback from the black daisies and negative feedback from the white ones. Together, they regulate the planet's temperature, producing a stable environment despite the changes in solar radiation. The daisy world model is a very general one, and you can play all manner of games with it. So let's make it more realistic by giving the daisies a few problems. For example, we could introduce rabbits to feed on the daisies. At first, the rabbits would try to eat up all the daisies, but as the daisies became scarcer, the rabbits would starve. So the rabbit population would decline as a result. If then the daisy population recovers, this will be followed by a recovery in the rabbit population. This is another example of a positive and negative feedback system which balances out over time. So if the rabbit population fluctuates like this, the daisies correspond like this. During the population cycles, there appear to be runaway increases or decreases in the number of rabbits or daisies. But when measured over a long time, a balance or equilibrium has been achieved between the number of daisies growing and the number of rabbits supported by them. This balance means that the rabbits have little effect on the long-term well-being of daisy world. The same long-term balance will eventually be achieved even if we introduce further biological perturbations. We could, for instance, introduce foxes to prey on the rabbits, or a plague to kill off a high percentage of the daisies, or competition between daisies of different colours, or whatever perturbations we may care to invent. The effect of feedback is a zone of quite remarkable planetary temperature stability in the face of quite massive changes in solar radiation. As the output of the sun varies, so the black and white daisies simply respond to changing conditions. But in doing so, they regulate the temperature. The process is entirely automatic. It's just an emergent property of the system.